So in this video we're going to graph a linear function that's in slope-intercept form by finding the function's intercepts. But we're going to do this in the case where we have rational intercepts that are not nice integer values. We want to emphasize that these don't have to come out perfect every time. So find the intercepts of f of x and use them to graph f of x. So again, we want to remember that the y-intercept occurs when x is equal to 0. So we're trying to find 0, comma, f of 0. Input 0, output f of 0. So to get the y-intercept, we just plug 0 into f of x. So we get 5/3 times 0 plus 5/2. And 5/3 times 0 is 0. 0 plus 5/2 is just 5/2. So we get the ordered pair input 0, output 5/2. There's our y-intercept. And then we want to remember that for the x-intercept, we don't know x, but the output of the function is 0. So we're really needing for 0 to equal f of x. So we need 0 to equal the expression that describes the function f of x. So that expression is 5/3 x plus 5/2. So it looks like we need to subtract 5/2 from both sides, which would give us negative 5/2 equaling 5/3 of an x. And then it looks like we can multiply both sides by the reciprocal of the coefficient on x, so multiply by 3/5. Multiply by 3/5 on both sides, because 5/3 times 3/5 is 1. We get the product is 1 when we multiply reciprocals. The product of reciprocals is 1, so we get 1x. And here this is going to become negative 3/2. So it looks like when we input for x the value negative 3/2, we get an output of 0. So here is our x-intercept, and here is our y-intercept. So next what we need to do is graph these. So I'm going to go ahead and set up my axes, my vertical axis, my horizontal axis. This is my x, this is my f of x. I have arrows on my axes. 5/2 is the same as 2.5. Negative 3/2 is about negative 1.7-ish. So 5/2 is a little bit taller than negative 3/2. So what I would do is I would recognize that if I'm input 0, output 5/2, wherever I decide to put my y-intercept, I'm going to need to have my x-intercept a little bit skinnier than that, because this is going to need to be about negative 1.7, whereas this distance here is going to need to be about 2.5. I don't need to get this perfect, I just want a nice sketch of the function. So I'm just going to go ahead and draw in a line that makes my y-intercept a little bit taller or higher than my x-intercept is wide. So I'll just come in, I'll sweep a line in like that. And then, like we did in the previous video, once we draw in the linear function that roughly matches what this is supposed to look like, we can then label in the intercepts afterwards. This is input 0, output 5/2. There's my y-intercept. And this one here is input negative 3/2, output 0. And then we want to make sure we have everything that we need to get for full credit. Both intercepts are labeled. I have arrows on my linear function. I have arrows on my axes. My x and my y axes are both labeled. I would take f of x or y for my vertical label. Either one would be sufficient. So this looks like it's good enough for government work.